to try to wrap up chapter 3 before Thanksgiving break. So my plan right now is we're going to do section 3.3 today and tomorrow. Tuesday and Wednesday, section 3.3. On Thursday, we're going to take a really short quiz. Like, there's 2 questions on this quiz short. It's that short. After the quiz, you'll have some time to finish up your study guide. Friday, we'll review, and then we're going to take our test on Monday. Now, if you and your family are going to be out of town, or you're not going to be at school next Monday, it would be in your very best interest to take the test on Friday. Otherwise, what's your next best option? Monday after Thanksgiving, when you had an entire week to forget about it. Okay, so if you're not going to be at school next Monday, please let me know in advance, and I will have a test ready. You can take it on Friday in class. So real quick, section 33, today and tomorrow. Thursday we have a short quiz. After the quiz we work on our study guide. Friday review, test on Monday. I'll post all that on Google Classroom so you guys have that. Today we're going to cover section 3.3. You should all have a notes page and hopefully a ruler as well. So this section is on graphing systems of inequalities. We have graph systems of equations, and we've graphed linear inequalities. We're putting the 2 ideas together. You guys can graph an equation with no problem. You should be able to graph that in linear inequality with no problem. If we see that inequality in our problem, what do we know that we need to do in addition to graph the line? We did this last chapter. Shade. You're going to have to shade one side or the other. Okay. Dave, are you with us? So I want you to graph both of these on your notes page. As far as graphing, I don't care if you use slope-intercept form. If you want to use your intercept, that's fine. But if I'm looking at these 2, I think it's going to be easiest in slope-intercept form. Do you agree with that? Mm-hmm. So let's take that out first. So our first inequality has a y-intercept at -3. So let's go to our y-axis and put a dot at -3. The slope is 2. That means rise 2 and run 1. Would this be a dash or a solid line? How do we know it's solid? It's equal to, greater than or equal to. So take your ruler and draw in a solid line. Now remember, we see that inequality, we have to shade one side or the other, don't we? So how do we know which side to shade? What point do we want to test? 0, 0. So just like we did last chapter, we'll test 0, 0. Two times 0 is 0, and 0 minus 3 is -3. Is 0 greater than or equal to -3? Yes, that's true. So we want to shade on this top side, the side with 0, 0. Please just lightly shade on the side with 0, 0. Lightly shading with your pencil on the side with 0, 0. So for the second inequality, the y-intercept is at +1. So I'm going to put a dot at 1, and the slope here is -1. For this second line, am I going to use a dash or a solid line on my graph?
Probably dash.
How do I know it's dashed? It's not equal to, that's right. So take your ruler, and we're going to draw in a dashed line. So just like in the previous graph, we wanted to test the point. We're still going to test 0, 0. So 0 less than, the opposite of 0 plus 1. Is 0 less than 1? That's true. So again, lightly shade on the side with 0, 0. So for my red graph, it's going to be on the bottom side. Now I would like for you to go back and darken the region where those shadings overlap. If you've got a highlighter, you can just shade in that region where they overlap with a different color. That would work, or you could just darken it up with your pencil. That's fine. So my yellow region is the region where the shadings overlap. What does that region represent? Well, what did the blue region represent for that graph? Well, let me ask you, are you thinking those are true solutions or are they false solutions? True. So the region that we shaded in blue was all the true ordered pairs for that inequality, right? So the red region that we shade, those were all the ordered pairs that were true or false? True for the red inequality. So the yellow region, where I darkened it, those are the ordered pairs that are true for both.
Alright, oh.
The yellow region is our is the area where the ordered pairs are true for both. There is no number answer we need to give. Your graph is the answer for today's problems. Let's try this one. These are once again in slope-intercept form. We can use slope-intercept form to graph them. If they weren't, you could use intercepts. Put them in slope-intercept form. I'm leaving it up to you. So first inequality, the y-intercept is at 1, so put it out at 1 on our y-axis. The slope is negative 3/4, that means down 3 and right 4. Down 3 and right 4. And also go up 3 and left 4. Up 3 and left 4. We'll use a dashed or solid line for this one. Solid line. Okay, so now we need to test a point. So we did in the last example. We're going to use 0, 0. Was there ever a time where we couldn't use 0, 0 as our test point? That's right. If our line goes through 0, 0, we can't use it. So I have 0 is greater than or equal to 1. True or false? Oh, that's false. So we don't want to shade the side with 0, 0. We want to shade the side opposite of 0, 0. So that would be the top of my graph. inequality, they have the same slope. So what's that going to make my two graphs? Yeah, they should be parallel. So the y-intercept for that second one is at -2, and the slope is once again -3/4. Down 3 and right 4. Up 3 and left 4. Will this one have a dash or a solid line? Solid as well. So go ahead and test 0, 0. -3/4 times 0 is 0, and 0 minus 2 is -2. So I have 0 is less than or equal to -2. Is that true or false? False. So I don't want to shade the side with 0, 0, I want to shade the other side. So it would be the bottom half of our graph, underside. So where do these two graphs overlap one another? They don't. So let me ask you this. Will they ever have, or will there ever be, an ordered pair that would work for both of those inequalities? No. The red region, the shaded red region, are all the ordered pairs that work for the first inequality. The shaded blue region are all the ordered pairs that work for the second, the blue inequality. They don't have any in common, do they? So there would not be any solution for either one. We could say no solution even because they won't share any solutions in common. Different type of problem. So this one is left-hand column. It's the bottom one on the left-hand side on your notes page. The directions are a little different than the previous problems. It says to find the coordinates of the vertices of the triangle that's formed by these three inequalities. First of all, what are vertices? Vertices of the triangle. What do you think vertices mean? Let's think about what a triangle looks like. We're trying to figure out those points. So each of these inequalities is representing a side of our triangle. We're trying to figure out where those lines meet and identify the vertices. Does that make sense? Okay, so let's graph each individual problem and we'll find the vertices. So the first one, we have a y-intercept at -8. Y-intercept at -8. And the slope is 15/4. Rise 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And over 4. 1, 2, 3. Up 15 and right 4. Now I definitely don't have enough room to rise 15 and run 4 more. So 2 points is all that we're going to need here. Would you use a dash or a solid line for this? A solid. Now, normally we would shade one side or the other because it is an inequality, correct? But my goal here is not necessarily the shading, it's to find those vertices, so I'm less worried about the shading and more worried that I've got my line in the right position. It's going to form a triangle, I promise. Let's make sure we can find the vertices. The second equation or inequality is y is less than 7. That's like y equals 7, correct? That's going to be a horizontal line at 7. gonna go up to 7. 1, 2, 3, 4, 5, 6, 7. I'm gonna draw my horizontal line. Now, will this one be dashed or solid? Dash. So go ahead and draw a dashed horizontal line. Now, I believe at this point I know what one of my vertices is gonna be. Do you agree with that? You figure out what my third line is going to be, but I already know what one of the vertices is. Let's go ahead and write that down. What is the first one here? 2, 3, 4. 1, 2, 3, 4. And up 1, 2, 3, 4, 5, 6, 7. 4, 7. Do you have a vertex? Two lines are meeting here. Now for this last one, it's not in slope-intercept form, is it? It's not yet, but let's put it in slope-intercept form. What could I do? Divide by 4. So I have y is greater than or equal to negative 15 fourths, x minus 8. So y-intercept down here at negative 8. And the slope is negative 15 fourths. I don't want to go down 15 and right 4, do I? Better choice is to go up 15 and left 4. 1, 2. This one will be a solid line also. So as you draw in that last line, that last inequality, we can see that the region that's formed by these inequalities is this right in here. If we were to shade all 3 sides of these lines, it's going to get kind of crazy. It is going to get too dark to see. So I kind of hold off on my shading. It's clearly going to make a triangle. We've got that formed. Now let's identify the 3 vertices. Okay, we've got 4, 7. Right over here. 4, 7. That was the one we established a second ago. We have a point of intersection, a vertex here on our y-axis. What's this ordered pair? 0, negative 8. And we've got one more over here. Negative 4, 7 is correct. Alright, I've got one more example. Let's do this one. I cut off by the problem. It says Louis has 2 jobs and can work no more than 25 total hours per week. He wants to earn at least $150 per week. Graph the inequalities to show the possible combination of hours worked in each job that will help him reach his goal. Now it does tell us that as a busboy, he can make $6.50 per hour, and as a clerk, he can make $8 per hour. What do we not know in this situation? We don't know how many hours he's working as a busboy or as a clerk. Let's start with that. Let x be the number of hours as a busboy. And let's let y be the number of hours as a clerk. We know how much he's going to get paid for each hour. We know how many total hours he can work. We know his total pay or what he wants to make. So we can use all of that information to help us write 2 inequalities here. If he makes $6.50 per hour as a busboy, we're going to take $6.50 times the number of hours, x, as a busboy, plus he was going to make, or he could make, $8 per hour as a clerk. So this is $6.50, $8. On the other side of our inequality, we need money. What number can we put over here? 150, yeah. Now it does say at least $150 per week. What inequality symbol will show at least? Greater than or equal to. Does anyone see any other information in this problem that would be helpful in writing the second inequality? Jimmy? I'm sorry.
No more than 25
You can work no more than 25 hours. How could I write an inequality with that? Okay. Very good. She says x plus y, number of hours as a busboy, plus the number of hours as a clerk. It says no more than, so that's less than or equal to the 25 total hours. We should be able to graph both of these inequalities on the graph, and I know it's small, I apologize, just do your best. Let's label each axis. I'm going to let x-axis be the number of hours as a busboy, just like we identified here. Busboy hours. On the y-axis, I'm going to let that be work hours. My y-axis says clerk hours, my x-axis says busboy hours. For graphing purposes, I think using intercept is probably going to be the easiest way. So if I want to find the x-intercept of the first inequality, I'm going to cover up the y term. So 150 divided by $6.50. That x-intercept is going to be, you have about 23. So the x-intercept, I'm just going to write it down, is 23. The y-intercept, cover up x, I'm going to take 150 divided by 8. That's 18.75. I'm just trying to get my x and y-intercept for both of these, and then I'll decide what I'm going to go by on my x and y-axis. Now for the second inequality, do you agree that both the x-intercept and y-intercept are 25? What do we want to go by? Choose. Get there? Let's spread this out a little bit. So I guess I'm going to go by ones on my y-axis. I'm just labeling every other box. Space, I can go to 25 on my y-axis, no problem. On the y-axis, I might need to go by, I think I'm going to go by ones, because I need to get to 23, I think I have 20, 21 blocks, I'm okay. Let's go by twos here. Go by ones, I'm labeling every other box. By ones. So I'm going to do 22. We'll just approximate where 23 is going to be. It doesn't matter what you go by, does it? You can pick and go by whatever you want. I'm just trying to maximize the use of my graph paper. The bigger I can make the graph, the more accurate it's going to be. Alright, so let's graph both of these inequalities. The first one I have an x-intercept at 23. Let's be there. And I have a y-intercept at 18.75. That first inequality is going to be a solid line. I'm graphing this first inequality right now. do need to shade one side or the other. If I test 0, 0 in there, it's going to be 0 is greater than or equal to 150. Is that true or false? False. So I want to shade the top side and the right side. So just lightly shade on the top half of this graph. For the second inequality, I have x and y intercepts at 25. Again, a solid line is needed. If I test 0, 0 here in this second inequality, I have 0 is less than or equal to 25. That's true, so I want to shade the side with 0, 0. So when you're finished with all your shading, go ahead and darken the region where those two shadings overlap one another. So what is that darkened region representing? What's that? Yeah, all the combination of hours he can work. That would be no more than 25, and he would make at least $150. So one combination might be 12 hours as a busboy and 11 hours as a clerk. You could work 4 hours as a busboy and 19 hours as a clerk. Any combination of hours worked that are in that yellow region will satisfy his needs. Alright, I'm going to stop here for today. We are graphing systems of inequalities. Remember, you can use any method to graph. You can use slope-intercept form, you can use x and y intercept. It's up to you. You do need a textbook for today's problems. And I'll pass out some graph paper. Can I borrow somebody's book to screen capture?